Hello and welcome to Connect and Collaborate. I am Alex Hopkins, your on-air producer. I am so excited because all week long I have been talking Colorado Business Roundtable partnerships. And so one of our big partners here in the Colorado area is Lockheed Martin. But before I introduce you to our guest, I'm going to ask our audience out there to please visit cobrt.com. Sign up for our newsletter. It comes out every Tuesday. And also sign up for our View from the Top event with CEO panelists that is happening August 20th. Check out this podcast and more on our radio page while you're there. And I'm going to go ahead and introduce our guest. This is Bill Pratt. He is the program manager for NextSTEP Lunar Habitat at Lockheed. How are you, Bill?
I'm great, and thank you so much for inviting me here to talk about the exciting things we're doing at Lockheed, and also stuff that I love that's near and dear to my heart, and that's the NextSTEP program and what we're doing about the future of human spaceflight. Thank you.
Fantastic. Yeah, our pleasure to have you here. It's exciting stuff. But before we get into what NextSTEP is and what Lockheed's doing, let's talk about you, Bill. One of my favorite guests to have in here are aerospace guys, right?
Oh,
you guys always seem to have a really interesting background, and you've got the stars in your eyes, so to speak, right? From a young age, you typically want to be astronauts or get into the aerospace field somehow. So let's hear your story.
So you kind of described it. Yeah, I've been interested in science and math from a very early age. When I can remember second grade being, it sounds odd, but being inspired by the Challenger accident, which really affected me in a way that is hard to describe. It was, a tragic event, but when I watched it unfold, I remember exactly where I was and just thinking, what a brave group of men and women were, and I wanted to be an astronaut from then on. So that's like a typical story for aerospace engineers. They want to be astronauts. But life took me down a little bit different path, and I took sort of my passion for math and science, and as I went into college, I thought I was going to go into medical school. However, in my first class in physics, I learned about how you can model the world, simulate it through physics and science and math, and I was just hooked. And so a couple weeks later, I was in the aerospace program at the University of Colorado, and have just been sucked in ever since.
What did you want to do in the medical field?
Just be a doctor.
Oh, okay.
Yeah.
All right.
Yeah, basically, yeah.
Yeah.
I hadn't thought it through much more than that.
A lot of us really end up in college going, you know what, I think I'll do this, right?
Exactly. Yeah.
So I'm curious, what took you down a path of medical? Because you did mention that second grade you saw that Challenger incident, right? And
yeah, I think it was sort of the hands-on nature of medicine, and also I really like working with people. Okay. And so, the thought of getting to interact with patients and the science component of that too was really interesting to me. And I think, when I did enter into college and I started taking more science and math and the physics, it really kind of, I think, reawakened sort of that passion in me for those fields. And I'm a big simulation guy. In my early career focus was on doing trajectory simulations and how do we get spacecraft from here to Mars and other planets and things like that. And so that really all comes from just learning that almost everything we observe in our everyday world can be more or less boiled down to equations, right? And you can simulate almost everything. And so, when I learned that, I was just totally hooked. And that's really just what got me going.
Right on.
Yeah.
So I think one of the preconceived notions about working with aerospace and engineering in particular is that you don't get a whole lot of human interaction.
Certainly, yeah.
Yeah. So are you missing that piece from what would have been being a doctor, or?
Maybe, but I'm just a very collaborative person. So the people that I choose for my team and the way I interact with people, it's just, it might be a bit of an oddity in aerospace engineering, but that's just who I am. And so I resonate with people who are similar. I really, one of the things I love about this industry is the collaborative nature and the high caliber of people that you encounter. At Lockheed, we have just some of the smartest people I've ever met, and it really gets me up every morning to think about working with these people and trying to face challenges and help customers solve solutions, or find solutions to challenges. And so that's just the way I work.
Awesome. Well, so let's talk a little bit about some of your favorite projects that you've gotten to do. Again, we'll talk about Next Step, but I'm going to save details for that for later on. But over the years, what do you look back on and be like, yes, that it confirmed where I needed to be? Yeah.
So when I started at Lockheed, I worked on the Atlas program, which was a launch vehicle, and it was sort of tailing off towards the end. And I've worked on Propulsion, so I helped design some of the parts that fly today on the upper stage, which is the Centaur upper stage. And so from there, once I kind of wound down, I moved into human space flight. And so I had an opportunity to work on sort of a lot of the predecessors to what's now called the Orion program. So it's acronym soup. There's many of them. But yeah, slowly, you know, they're still early in my career, so I learned a lot of how do we simulate the trajectories to get the humans from the ground up into orbit, and just worked on those different projects, and then actually took a break and went and worked for a small company in Thornton at the time called Space Imaging. And so then I got some operational experience with their Icono satellite and learned how these things that I was once designing, how they actually get operated at the end, which was sort of a great eye-opening experience for me. And then took that experience, and when Lockheed won the Orion program back in '96, I think, you know, I made my way back and was there on the Orion program for a while, and I worked on what was called kind of the Pratt Abort program, which so for any human spaceflight vehicle, you have to be able to abort the mission in case of an emergency. And so on the Orion spacecraft, they have something called a launch abort system on top, which is essentially another rocket, a whole other rocket attached to the top of it to pull humans off in the case of an emergency on the pad or early in ascent. And so I did a lot of the simulation for that, did a lot of the range safety for the test, and we actually, I think in 2010, we had the Pad Abort or PA-1 test out at White Sands Missile Range. And that was really a highlight for me to work, you know, something from beginning to end, to actually go out in the desert and test it and watch it launch. I mean, that's sort of anyone in aerospace, that's kind of the culmination, right? That's the brass ring, is to see something you've been working on for years actually get to fly. And so that's probably one of the bigger highlights of my career, for sure.
That's, well, I'm sure that's super rewarding. That sounds amazing.
Yes, it was.
Yes. So let's talk a little bit about Lockheed, right? If you don't mind. So we know that they're a big staple in Colorado, mostly for aerospace, but also on the defense side of things, which we've had several guests from the defense side, but I always get really vetted hardcore before anyone comes on the show. And so you're more for the commercial side of things. Commercial and human space flight.
Yeah, so the way our company is, you know, the space side of the company is divided up, you definitely have the military space, but then you also have commercial and something that we call civil or deep space exploration, which is where we build the probes that go to Mars and other places, and then of course human space flight, which is where the Orion program is. And so I actually work within an organization called Advanced Programs. So we work on concept development for missions and new spacecraft early in the design stage. So that's where NextSTEP comes in. But I tend to focus more on the human space flight side. We have other folks who work the you know, the new NASA probes and things like that, and the commercial weather satellites and things like that. So we really have a wide range of things we work on at Lockheed, and that's really one of the things that drew me to Lockheed as a company. You know, also being a CU grad, that was pretty nice. But just the wide range of possibilities and projects that you can work on. It really, there's always challenges, new things to explore and to do.
Yeah. So the majority of your career has been spent at Lockheed then,
Yeah, most of it.
Okay.
There were a couple years, like I said, at Space Imaging, but most of my time has been at Lockheed. It's hard to get bored.
I would imagine. Well, and we all know one of the great things about the aerospace industry throughout Colorado is the collaboration, as you mentioned before. But one of the few industries I think that really hones in on that collaboration effort across the board. And we have tons of engineering and manufacturing companies, right, that are, 6 to 7 people at a company that, like, Lockheed doesn't think twice to, hey, can you help us with this part or whatever you need?
It's a team sport, for sure. And, you know, when you think about all of the parts and the systems that have to go into a spacecraft, it's a multidisciplinary team sport. And, you know, again, going back to what I said earlier, it's just that's one of the things I love.
Yeah.
Yeah.
Awesome. Let's talk a little bit about Waterton.
Yeah. So Waterton is sort of the main facility in Colorado for Lockheed, although we have a lot of satellite areas. We have offices and facilities in Colorado Springs all the way up to Boulder, right, where the SBIRS program is run out of. But in Waterton itself, I think we have somewhere around 5,000 employees there, and Colorado-wide about 9,000. So it's a pretty big employer for Colorado, and in fact, over the last 4 years or so, we've grown. We've added about 500 new jobs in the Colorado and Denver areas. So, you know, that just gets to the wide base of things that we're doing and projects that we're working on. So, yeah.
Awesome. Do you mind giving us a little bit of background about it? Because it's been around since 1956.
Yeah. And back then it was, you know, it was sort of built. Waterton itself is pretty big. It's about 5,600 acres.
Oh, wow.
Yeah, it's a large facility. In fact, if you want to, you can board your horses there. We have horses there, and we have elk and wild turkeys and all sorts of stuff. It's such a big swath of land there. But we have somewhere around 30 or 40 buildings, and in the early days, it was really built for the Titan missile program. And so you can actually, you know, drive around there and see some of the old artifacts from all the way back then. And back in the day, it was really cranking out not just the missiles, but then kind of evolved into the Titan launch vehicle, and then the Atlas launch vehicle. So all of that is sort of the early heritage, of course, going back to the the Marietta days, right? And you know, now of course we don't do any launch vehicles here. Of course, that's all done somewhere else, and that's with ULA. But now it's mostly focused on satellites and you know, the different payloads. So we've got, like I said, the military space, but also the most state-of-the-art GPS, new advanced GPS systems, to Mars probes, interplanetary probes, and then of course the Orion program with human spaceflight. So it's really kind of morphed. You know, the move into the interplanetary stuff sort of happened with the Viking program, which I love, and that was all done here in Denver too, which is cool because Carl Sagan is a hero of mine, and he used to haunt the halls there at you know, in some of the buildings. So there's that really strong heritage going back to into the 60s. So.
Yeah, that's really exciting stuff, and I love to see that Lockheed's grown, right? It's huge help to the economy here in Colorado.
Yep.
And speaking of which, I know that we're growing. Do you mind touching on the Gateway Center for us? Yeah.
So the Gateway Center is really exciting. It's a large investment, about a $350 million investment in what we're calling the factory of the future, and it's a almost 3,000 square foot facility that will produce a wide range of satellites, anywhere from nanosats, so these are small satellites, up to our most powerful line of what we call LM-2100 satellites, which is our commercial line of spacecraft. And you know, this building is state-of-the-art. It's packed with innovations and built for versatility. And the main idea here is to kind of co-locate everything into one building to speed production, lower costs, and to really kind of consolidate all of the different stages of building and designing a spacecraft into one location to really provide that value to the customer and reduce costs.
Okay.
Yeah.
So what does that mean for your other facility?
So those will still get used. So so right now we have different, you know, test chambers and things like that on site, but those tend to get oversubscribed for other things. So this allows us to kind of create one area where we can share the facilities in a more efficient way, but the other facilities will still get used. Yeah.
Nice.
Yep.
That's exciting.
Just kind of expands capability.
Yeah. So let's talk about some maybe future projects that are on the horizon.
Right. So I can't speak for the whole company. There's a lot of new
Of
stuff
course.
coming on.
I would never expect for you to.
But there's a lot of really exciting stuff in the human exploration field, and we'll talk a little bit later about the NextSTEP program. But on the Orion side, we had our EFT-1 test flight a few years ago, and now we're looking forward to EM-1, which will be in the next few years, and then leading to our first crewed flight of that spacecraft. So the first time we've put humans into deep space since the Apollo days. So that's exciting. And then beyond that, we're starting to look at what's the next destination for humans in deep space. And so that's we'll start at the moon with the president's latest declaration, and then work our way towards Mars in the next couple of decades.
I got to ask you about Mars. Can we
Sure.
talk about that one? Because that for me was very exciting. We had Rob Chambers on back in March.
I can't do as good of a job as Rob, of course.
And that's quite all right. But that's kind of his baby, right?
Oh, yeah.
So that's fair. But yeah, this exciting stuff.
Very exciting. It's I just read something recently where NASA said that the first people to go to Mars are alive today, and that's really exciting.
Yeah.
And of course, we're going to take steps to get to Mars, and that's where the cislunar or the gateway stuff comes in. But I'm a big fan of The Martian, and the thought of my kids getting to be potentially take part in that is really, really exciting.
It is really exciting. So let me ask you: would you go? Would you go on the first mission? If you obviously,
man. That's a tough one. I would really love to go.
Yeah.
I would really love to go. If we built it, I would definitely go.
Oh, okay. Oh, wow. All right. That's not a recommendation for Lockheed. I don't know a good one. That's something it is tough to answer that, right? Because I would imagine that the first group that goes probably won't be coming back.
I hope they come back.
Well, no, sorry.
But some may choose to stay, right?
Right.
Yeah.
Exactly.
Yeah. It's that's interesting. I think NASA definitely has in mind we're gonna bring them back. But I know the others are thinking that let's go and start to build up kind of a colony there, and not and leave people there to sort of build up the infrastructure. And so that's one way that we might do it. Yeah.
Okay, but there's no final.
Definitely not. So
Okay.
there's a lot of planning that goes into doing a Mars mission, and NASA's still, studying that and trying to figure it out. But the first steps are trying to take what we've learned on the International Space Station and start to practice that and take that to a more distant location, like around the moon, and really start to practice there before we push onto Mars. And Mars is quite a bit further away than the moon, and the complications with communication back and forth to Mars, all that stuff are things that we've got to practice here before we go and do that there. Yeah.
Can you tell us about any of those details, particularly communication? How do you test that?
Well, so just to kind of describe to you the challenge here, it's the round trip delay in communications from the moment you say, Houston, we've got a problem, to when you get an answer back could be up to 40 minutes. Wow. Depending on the position of Mars and Earth respectively. And so that really drives a lot of self-reliance into the design of the spacecraft. So astronauts have to be able to be a lot more self-reliant than they have historically been on shuttle or ISS. On the International Space Station, if we have a problem, you can just push the button and come home in a matter of hours. At the moon, it's more like a matter of days, but at Mars, once you start, you're committed for the next 18 months, 2 years, whatever. And so you have to build in a lot of that redundancy and self-reliance into the spacecraft to allow astronauts to fight sort of the time-critical emergencies that might crop up, and give themselves a chance to get in a safe configuration before the ground control can interact and help them out. So it's quite a different scenario. Yeah. And that you can practice that, and they've done some of this on the International Space Station, where you can add artificial delays to your communication. When you take that to the moon, the delay is a little bit longer, but it's nowhere near that. You're talking a couple seconds, really. But the fact that you're at the end of a thin logistics train, or chain, and you can't send supplies up right away if you have a problem. Really kind of forces you into that mindset of thinking about, how am I going to stay and fight, and or do I go home, and how do I troubleshoot these problems that come up?
Yeah. So obviously we invest a lot in training our astronauts
Right.
to make sure they're the best of the best out there. Would you say, though, with this technology, I'm sure we have to have some safety practices in place.
Yes.
And while technology obviously has gotten lots better in the last time we sent humans into space, are they going to require that much more training?
So I think the training, I think there will be more training, but I think the interesting thing about training for a long duration space flight is that it's hard to keep a human current on every possible scenario that might come up. And so that's where the self-reliance piece comes in. We can talk a little bit more about this later with something we've thought a lot about, which is something called a digital twin, which is sort of a complete onboard digital representation or virtual representation of your spacecraft and its environment that's at your fingertips at all times. So that really allows you to do something that we call just-in-time training. So when you have an issue that pops up, you have the ability to pull up, the instructions or the training on how to react to that situation quickly. And so astronauts, they'll have a lot of time on the way over, so they'll be continually training during the flight over, but also being able to call upon, something like a digital twin to help them troubleshoot we feel is a key aspect to that.
Yeah, I would imagine that's really nice. I'm imagining commercial flight, right?
Yes.
Yeah. So a similar system to that. You've got
I kind of think of it as like Jarvis with Iron Man, right?
Okay. All right.
Kind of the ability to have digital assistants are everywhere today, right? And so the ability to have, sort of a smart assistant that can help you walk through the steps, and that's where you start to think about using things like virtual reality and augmented reality. And that's one of the things that's we do a lot of in Denver. Is we have a state-of-the-art virtual reality lab there that we test a lot of this stuff in, and the pace of that technology is just unbelievable.
I would imagine.
Yeah.
So we've got a couple minutes here.
Yeah.
I want to ask you, in the years that you've been working at Lockheed, do you have any favorite stories that you want to share with us?
Oh man, I already shared kind of a couple of them.
Well, yeah.
Definitely the Pratt Abort launch.
Yes.
That was, and then also the EFT-1 flight, getting to participate with that. The first time we had launched, a space capsule into beyond low Earth orbit. That was extremely exciting. Also opportunities to meet different folks. So, one of the things, I have a picture in my office of me and Bill Nye the Science Guy.
Nice.
So that's one of the things that just getting to meet the different folks that inspire the next generation of scientists and engineers, and I've really enjoyed that too. Those are probably some of the highlights that I could think of. Of course, the NextSTEP program, which we'll talk about in a minute, is a pretty big one for me too, and I'm looking forward to chatting about that.
Yes. Do you want to do a quick intro for it before we go to break, and then we'll
tease
jump
it a little bit?
Tease it a little bit.
Yeah. So the NextSTEP program, NASA, as the Orion spacecraft is nearing completion and ready for flight, and the SLS, the rocket that's going to take it, NASA's looking at what's the next step, pun intended, for human space flight, and where are we going to go next. And so that's really what we're helping NASA understand. They have this idea that we want an orbiting platform around the moon, and we'll talk about the reasons for that, and what are the challenges associated with that. We're actually building some prototypes of some of these habitats, and so that's all very exciting.
That is very exciting, and we're going to get into that in our next segment.
Perfect.
Stay with us here on Connect and Collaborate. Be sure to like and subscribe our YouTube page while you're here, and check out Lockheed Martin and all the exciting things they have going on, including this next step. You can follow along in our next segment. Stay with us here on Connect and Collaborate. Thank you for staying with us here on Connect and Collaborate. I'm so excited. All week long we are talking covert partnerships, but today I have in studio with me Bill Pratt. He's the program manager for NextSTEP Lunar Habitat. So thank you, Bill, for hanging out with us through that commercial break. Yeah. And so this is really exciting stuff that we've got going on. We talked in the last segment, we're looking at sending humans in space, and Lockheed's got a lot going on. But let's really dive deep into this NextSTEP Lunar Habitat.
Yeah, absolutely. So, we've collectively, the collective, we have, accomplished a lot of great things in low Earth orbit with the International Space Station and in the shuttle program. And so we've had missions where we've had humans in space, the same human for a year or more. And we've also sent humans to the moon, but in the Apollo days. Those were short duration missions, though, about 7 days. When you look at what it takes to get to Mars, you're talking something like 1,000 times further away than the moon is from Earth, and at least twice as long duration, right? So it's really, the challenge kind of boils down in my mind to a distance and duration problem. So that drives the self-sufficiency that we talked about last time. So NASA is looking at this problem and has decided that the best way to kind of a stepping stone towards that is to build what they call the cislunar gateway, or the gateway as we kind of shorthand call it, around the moon. And so the nice thing about that is that the moon is far enough away that you can't push the button and come home quickly, but it's close enough that you have days to get home, basically. So it really starts to force you to think about, how do we meet these challenges? What are the technologies we need to develop, the procedures and protocols, and how do we learn to live so far away from Earth so that astronauts can travel those long distances to Mars and be able to troubleshoot and to really survive those long voyages.
Yeah. Let me ask you real quick about this. So we've not sent anyone into space for this long before. Is that correct?
For the length of a Mars mission?
Mm-hmm.
No, not total. So a Mars trip there and back is 2 years or more.
Yeah.
And so I think the longest duration we've spent in space, or humans have spent in space, is on Mir.
Mm-hmm.
And I think that was something like 400 days.
Okay.
So not just a little over
a
year. Yeah.
So I would imagine then, how body-wise, right?
Yeah.
In a scientific biology term, do we know what kind of effect that's going to have? I'm sure we can simulate it a little bit at least.
A little bit.
Yeah.
We know there are lots of challenges. So the challenges associated with zero gravity or microgravity and the effects on bone loss and fluid shifting and eyes and stuff like that are all things we're studying on the International Space Station. And so I'm obviously not a medical expert, and I know that NASA is focused on making sure that we can meet those challenges. I think in the end there will be ways to mitigate those challenges through the way you select the crew, the times of the year that you fly missions. It's like, for instance, radiation. Depending on where you fly in the solar cycle, you can actually, if you're smart about it, fly a mission where radiation is almost not a problem at all. And that's not a lot of the general public knows about that, but they hear a lot about radiation. So there are smart ways to get around some of these issues. So yeah.
Okay.
Yeah.
I just had to ask for my own curiosity.
That's a good question. Yeah, and in the psychological effects, of course, of being on a long flight, they've simulated that on the ground. With 500-day missions and things like that. The High Seas mission that just recently ended. So we have some data on those psychological effects of being in a small group, small volume for a year or more, and there are challenges there, but we're starting to get a better handle on that. Yeah,
absolutely. Well, I'd imagine it's similar to any really military train, right? You're in a small group.
Sure.
You've got a small group of people that you're going to rely on.
Yes.
For an extended period of time.
Think Antarctica, right? We have people that spend long time in Antarctica, and it's a very actually analogous environment. Maybe not quite as long, but yeah. Similar.
Yeah. Well, what a great example. Thank you for that. I appreciate that. So let's talk about NextSTEP from conceptualization to where it's at now and where it's going to go.
Yeah, so NextSTEP is in its, we call it phase 2. It's in its second phase now. Phase 1 we ended about a year, maybe a year and a half ago, and it was a small study to help NASA when they were first starting to think about this idea of a gateway. to help them kind of understand the high-level issues associated with and challenges with that. So it was a lot of systems engineering, a lot of trade studies, things like that. With phase 2, they've expanded that a lot. So they're more focused more focused on the details of how you launch the pieces, which pieces. I like to think of them as Lego bricks.
Okay.
So each element in the gateway is sort of a Lego brick, and you can't launch them all at once. So which order do you launch them in? How do you put them together in space? And how do you get them to all plug and play with each other, especially if you have one module that comes from, say, Europe and another module that comes from Japan? How do you make sure that these two pieces are going to talk to each other and play nice with each other? So that's a part of the phase 2 study. But in addition to that, NASA has asked us to build a full-scale prototype of the HAB module. So that's something that's really exciting that we're doing. We've actually we got on loan something called a multi-purpose logistics module, which is a shuttle-era piece of space flight hardware, actually, that was designed to carry cargo to and from the International Space Station. There were 3 of them, and NASA loaned us one, and so we're actually refurbishing that to be sort of a full-scale demonstrator of our concept. And so in addition to that, we're also building kind of an avionics. Avionics are sort of like the brains of a spacecraft. So an avionics demonstration that we're doing for NASA to help NASA understand and to show that we can get Orion and a gateway to talk to each other. It's really important because the thing about the gateway is that humans may only be there for a couple months out of the year. So it's mostly untended, meaning that there's no astronauts on board. So when Orion comes up, it sort of becomes the brains of the operation, and then when it leaves, the gateway has to take over and tend to itself. So we're helping NASA understand that, and then a couple of little studies that we're doing for NASA too. So it's really exciting work. We've been going for it's an 18-month long contract that we have with NASA. We're a little over halfway through. So by the end of the year, we should be wrapping up.
What kind of results are you seeing right now?
It's really exciting. So we're looking at without getting too specific, the order of the pieces. So one of the first things that NASA wants to launch is something called a power and propulsion element. So we're helping NASA understand, since this will provide power and propulsion to the gateway, what kind of power levels does it need, and how much propellant does it need, and things like that. So really working a lot on that. We're also working a lot with other commercial partners, other smaller companies that maybe have experience on the International Space Station with hosting science and commercial payloads. How do we take that same model and take it into deep space, because that's a whole new market for customers. So doing a lot of work there, and then of course the prototype as it builds up is really exciting too. So it's coming along nicely.
Yeah, that is exciting stuff. So what's your goal, your personal goal with NextSTEP here? What do you want to see it do later down the road?
Right. Yeah. So, in my mind, I could see, us laying the groundwork with NASA, of course, for gateways everywhere. I could see us, building. I like to think of a gateway as kind of a port in space, and I'm a big Star Trek fan, so I think about, the Enterprise being built there, and so. We talked about Mars earlier, and I can envision us building that spacecraft that will go to Mars at the gateway itself, and using it as kind of a depot, so a jumping off point to further destinations, whether that's to the surface of the moon, which is the latest news that we have with the latest presidential direction to go to the surface, or whether we go to asteroids or to Mars. It really is kind of a jumping off point, a gateway to further destinations. That's really exciting to me.
That is very exciting.
Yeah.
I'm not even in the industry, and
but
it's
now you want to go.
I do. I really do. So let's talk about this deep space exploration, right? This is relatively new coverage that we're doing here, right? And so we're trying to take all sorts of precautions and make sure everything's very safe.
Right.
So let's talk about the lunar habitats and the deep space exploration.
Yeah. So in terms of what we're doing to increase safety and things like that.
Yes.
Yeah, so this really gets back to the self-reliance piece that we talked about. So when you launch a small crew to deep space, you really have to think about how you're going to address different problems that come up, such as do I have enough spare parts to fix whatever widget might fail on you, and so that really gets into, okay, what can we do with advanced manufacturing? Can we bring 3D printing onto the habitat to print new parts rather than taking, spares of every single part with you because you can't spare that? It's too costly to do that. Can we just print parts? And so can we build a catalog of parts that might fail and be able to replicate them? So that's one thing we're doing. Another thing that we're looking at is something that we just recently announced called Maya, and Maya stands for Model-Based Artificial Intelligent Assistant. And so this is really this idea of the digital twin that I talked about before, and that's really exciting because what it does is it provides a virtual representation of the spacecraft, which is not something that's totally brand new. We actually do that with our planetary spacecraft and our commercial spacecraft. We have ground-based simulations, so if we have issues that come up or we need to test a new maneuver or something like that, we can do that on the ground. So that part's not new. But the exciting part is providing that in the hands of the astronauts so that they have the ability to access the same information and get the same and run the same simulations that you can on the ground, and that's because of the time delay that we talked about before. And so when we think about what a digital twin needs to look like for deep space flight, we sort of break it into 4 categories, and that's human interfaces. So if you look at kind of what the shuttle cockpit looked like, a lot of buttons, a lot of older looking screens, there's older technology.
It's reliable.
It was very reliable, yeah, no doubt about it, and on Orion too. But you look at just the explosion of tablets and voice control and augmented reality, virtual reality, all those things that even when we started building the Orion spacecraft were really not around, or at least not that far along. And so the ways in which astronauts will interact with the data and the models on the spacecraft depends on the task at hand. So some tasks might be better with augmented reality, so you put on the glasses and you see virtual work instructions overlaid on top of the physical thing that you're trying to fix. So it tells you step by step and even shows you with animations how to fix the thing that you're working on. To tablets that you can take with you anywhere in the spacecraft and get real-time data, instructions, pull up models and things like that. And then of course voice control. That's another exciting one too. So there's human interfaces. We mentioned the self-reliance piece. That's another big part of it. And then machine learning. So machine learning is you can't go very far without hearing about that these days. So there are some really exciting advancements in artificial intelligence and machine learning and things that we're doing at Lockheed, where we're looking at can we apply this field to detecting and solving spacecraft anomalies. So looking at data, you've got lots of sensors on the spacecraft, lots of data sources, and can we use machine learning to figure out, to point to problems before they happen, so we can address them early, or use them to solve problems and suggest solutions to problems that come up. And then Factory of the Future, which we talked about before, and that's really exciting too because it's, we are designing Maya today. In every model or simulation that we build, all of that goes into the spacecraft. So I like to think of it as you're designing the physical spacecraft alongside this digital one, because everything you're doing on the factory floor is being informed by the model. So it's really a cradle to grave sort of digital arc, if you will. And so we feel those are like the 4 major components to providing the self-reliance to astronauts.
I love this. We're actually like that. We're living in sci-fi, right?
Oh, it's that's. I tell you, Jarvis is like the
yeah. That's perfect example. That's hilarious, but it's so exciting where we are.
Absolutely.
And I'm so glad to have you here to wrap my head around this, right? Because it's crazy. I love it.
But it's all stuff that we can do today.
Yeah.
I mean, it's but 5 or 10 years ago, it would have been even crazier. But just the advancement of the technology is it's amazing, and it's something that across the company, across not just Lockheed and Denver, but across the whole enterprise, is something that we've really embraced. Is that digital? We call it the digital tapestry or digital thread across the entire, life cycle, if you will, of the spacecraft.
Yeah. Care to speak at all to some cybersecurity?
I am not a cybersecurity expert, so I would probably be a bad person to talk to.
No worries. Because it's a hot topic, and obviously
it definitely is.
I'm sure Lockheed has plenty in place to make sure that they're secure.
Absolutely, yeah. You can imagine that that's a pretty big deal for a company our size, and for the projects that we work on for the government. That cybersecurity and safety, that's like a pretty big and an important thing.
Yes.
At our company, yeah.
And speaking of working along with the government, I know that SpaceX, right? We've seen some amazing advancements in bringing space exploration to really the average Joe, right? What are your thoughts on? Are we going to see like missions to Mars for somebody, if they're willing to pay enough for it, they can go? Any thoughts on that?
I don't know. A mission to Mars is an expensive thing. What I think is probably more likely to happen is that governments will lead the way towards that and open, as I think is sort of customarily how things have kind of unfolded. I think Mars missions are big enough for everybody. There's a lot that we got to do to get to Mars, and it's probably too big for a single company to do that. And the marketplace for that, we'll see how that evolves, because today we've had some LEO market with some tourism on ISS, although not that much. Suborbital flights have still, there's a lot of stuff in the works there, but nothing yet. So I think it's really exciting. It's on the horizon, and we'll see where it goes.
Yeah. Let's talk a little bit about this open space.
Right, yeah.
That you've got going on.
So this kind of gets into what we were just talking about, and that's really opening up. We're trying to be more and more open with the things that we do, because with the advancement of technologies, you think about your mobile phone, your smartphone, and the sensors that are available just in that, and the things that people are doing, really kind of on a hobby scale. It's just amazing what people are able to create. And so the idea with that is to really try to share more and more, and we've released our payload specs actually for some of our small, medium, and large class spacecraft. And really the idea there is to allow people the ability to propose their own ideas for payloads or experiments or concepts for future missions. And so that's really exciting. You can go to our website, you can download the specs for these different spacecraft, and you can design your own payload for a spacecraft. And we'll even do our best to work with you, to partner you with other people who have similar goals or who want to fly similar spacecraft. And so I think that's a pretty exciting thing that we've just started.
Yeah, that's really exciting.
Yeah.
Gosh, no, I'd love to see that come to fruition. I want to ask you personally, for your career, and I know you mentioned you got to see something that you've worked on from the ground up and see it launch, and we talked a lot about examples of great place in the workplace. What are your major goals for the upcoming years? Before you retire, what is?
Oh yeah.
What's your prize that your eye is on?
Well, the NextSTEP program is like near and dear to my heart, and that's something where it's continually growing. There's a lot of interest and momentum building for that, which is a really great thing. We've I think sort of lacked that for a while in human spaceflight, and now we really have, I think, a great concept, a great program, and a great idea to go forward. And so I think for me, it's really just staying 100% focused on helping that become a reality in whatever way that I can, and really I look forward to the day when we launch that first element and we send humans to the gateway. I think it will open up not just new avenues for science exploration, but also for commercialization on a scale that we can only think of now. When I think about sort of the lunar economy that might come with that. It's pretty exciting, and how the gateway can be an integral part of that. So really for me, it's focusing on the gateway and making sure that I do what I can to make that become a reality.
Nice.
Yeah.
Well, I would love to see that happen for you as well. So we know that Lockheed does tons of internships, and you guys are very involved with workforce development and making sure that you get some really great education and educated individuals in Lockheed
Absolutely,
Martin.
yeah.
Any advice out there for students that are looking to have a career within aerospace, or are already in a program and trying to secure a job?
Yeah, it's it's intern season now, and so we actually have some really great interns that help us on the NextSTEP program, and they get the opportunity to do a lot of really cool stuff. For me, and I've talked to a lot of interns, a lot of folks coming out of school, and I would say, it's not enough these days to be good at math and science, but it's really kind of extending that passion into your own projects. Really taking what you've learned in school and applying it in ways that outside of your career. So. We talk to a lot of people who have built home automation systems, or who have done 3D printing and started their own companies and things like that. So I would say really try to get that experience where you can show that you're applying what you learned in school to other areas, so that you get a kind of a wider breadth of experience.
I love that.
Yeah.
Thank you for that. I'm sure any students listening out there take that to heart and make sure that they get some good abilities outside of work.
Yeah, it's really just kind of broadening those skills that you learn in school. And it's just amazing the things that you see, people who are graduating school these days, the projects that they've done, and a lot of that is done on their own time, which I think is pretty impressive.
Yeah, and I mean the technology, right? When you were in school versus what's available today to these students it's miles apart.
It's amazing, yeah. I mean, 3D printing wasn't even a thing.
Yeah.
And I didn't graduate that long ago.
After I said that, I heard myself. I'm sorry about that.
but no, and augmented reality, virtual reality, all of that, you're really starting to see kind of the, for lack of a better word, but this, DIY kind of culture, hobbyist, even my own son who's in middle school, just the things with programming and stuff that he's able to do, or that are at his fingertips. It's just amazing. And you can see that in the kind of graduates that we're getting now. So
yeah, that passion and the ability to be able to create that all on their own, right?
It's really exciting.
And that was definitely not a knock on your age so much as it was a knock on technology, right? It's definitely improved, and it's made lots of things great. Any last minute thoughts here on the NextSTEP program, or where we can find more information, anything like that?
Oh, definitely, yeah. You can go to our page at lockheedmartin.com, and I think we can provide the link later, but you can see we have a NextSTEP page there. And just look for us in the next few months. We've got the Gateway prototype that we're finishing, and that should be done closer to the end of this year, and we'll be releasing some news about that. And then after that, as NASA continues this program and starts bringing new elements online, it'll be really exciting.
Yes, great stuff happening. Thank you so much for joining us,
No problem.
Bill.
Thanks for having me.
Yes, of course. Be sure to check out Lockheed Martin and their NextSTEP program, and also the open space program that they've got going on. Be sure to like and subscribe our YouTube page while you're here. Check out this podcast and more at cobrt.com/radio-podcast. Have a great day, Bill.
You too. Thank you.
Thank you.